We've got 2x plus 3y less than or equal to 12. 2x plus y is less than or equal to 8. X is greater than or equal to 0. Y is greater than or equal to 0. And we want to maximize P, which is probably profit. I mean, it could be, obviously. I keep saying that because that's generally in business what we want to maximize. Now, let's find our feasible regions. Okay, usually it's in the first quadrant, so I'll write it out like that. We have to find the system, the solution to the system of all of these. Okay, so this is the system. The y's are greater than or equal to 0. So you're going to shade up. Since there's going to be an overlapping of multiple regions or half planes, I'm going to just do arrows. Now in green, so I just did that one. Now in green, I'm going to do x is greater than or equal to 0. So that's right here. That's where x is equal to 0 and all the x is greater than or equal to 0 are in that direction. And then in blue, I'll do these two. So this one is the same as saying y is less than or equal to negative 2x plus 8. That means you go up to 8, and then you go down to over 1. Down to over 1. And it's going to be a solid line because it's less than or equal to. Okay, and you could do a test point, and you'll see that 0, 0 works. So is 0 less than or equal to, or maybe it might not. Let's see, 0 plus 8, yes. That means we're going to shade this way. Okay, and I don't have so many colors here, so I guess I'll use green again. I like green. Now we have 2x plus 3y less than or equal to 12. I'm going to solve for y because I like to put it in slope-intercept form. Then we divide both sides by 3. So we get y is less than or equal to negative 2/3 plus 4. That means you go up to 4. It's going to be about here. Then you go down to over 3. I did that properly. And I'm going to check with the graphing calculator. And 0, exponents there. So 0 test 0, 0. So 0 less than or equal to 0 plus 4. Yes. So that means on this line, we're going to shade below. Okay, then we're going to do the same thing, which if you want to start getting ahead, because I'm going to switch to the computer and show you how to graph that with the graphing utility. We're going to do our vertex and the profit function. All right, so we have 6 times x plus 7 times y, 6x plus 7 times y. Okay, so the vertex, so you have to find where all of the lines, all of these feasible region points. Okay, so 0, 0 we can see is one of them. Our solution set. Where is our solution set? Where does everything overlap? It's here. So we are looking for these points. This one, this one, this one, and this one. So 0, 0 is correct. Go back to the green. So how do we find this one right here? So that's that one, 0, 4. And then let's look for this one here. This one is going to be on the blue line. So that's when y equals, to find that point, that's going to be when y equals 0 on the blue one. So it's going to be 2x plus 3 times 0 equals 12. 2x equals 12, divide by 2 on both sides. We've got x equals 6. So it's going to be 6, 0. And then the last point that we have to find. So find that last point. You can solve that by solving systems. I'm going to share my screen and do it. I'm going to do it with the Desmos. 2x plus 3y is less than or equal to 2x plus y less than or equal to 8. And then x is greater than or equal to y, 0. And y is greater than or equal to 0. Okay, so from Desmos, now we can see our feasible region. Okay, so here we have 0, 0 is one vertex. Here we've got the 0, 4, which we already found. Then we've got the 6, 0. And then the main one is here, the 3, 2. And you can find this one by doing substitution or the addition / elimination method. You can use any method or even graphing to find that vertex. And then it was 3, 2 as our last one. Okay. And now I'm going to plug in the points. And this is the final part, is to have 0. And then we have here 28. What is that, 36? This one's going to be 18 plus 14, 32. So it looks like our maximum is going to occur here. Unless I do this wrong, 18 plus 14. So this looks like our max. Okay, occurs at 6, 0 and is 36.